Next generation infrastructure for managers. So about 4 years ago, so I've been involved in this conference from day one, and I think Gene asked me maybe 4 years ago to do like Docker for managers, right? It was about the time where everybody was incredibly confused about Docker, particularly managers. Managers kind of there's a lot of variation in there what it means, but at the time there was really a lot of confusion, and that's fine, right? Everybody's kind of okay on the whole Docker thing, and then at London, it was kind of the conversation came up like Gene kept hearing about like service mesh and stuff like that, and he said, "John, do you want to do kind of something similar?" And I did it in London, and this is an updated version, so we'll go through it. It's kind of a catch-all. I got 30 minutes. I was like 29 minutes now to give you as much as I can tell you about the broad stroke of what the ecosystem looks like and what most people are thinking are the primitives that they're using. That's me. If you know who I am, then you know all this. If you don't know who I am, I've done tons of startups. Probably a lot of failed startups, but a couple of successes in the last 5 or 6 years. And one is a company I sold to Dell, and the other was a company that I created with a couple of friends called Socket Plane. We sold that to Docker, and I was at Docker for about 2 years almost, I guess. And then and I left, and now I'm with a company called SJ Technologies and doing really transformational consulting, which has been a lot of fun. I wrote the handbook and all sorts. I'm on the selection committee and whatnot. And I went back and I've actually authored. If you saw Snover's thing, like he was IBM, right? There used to be a really cool thing called Red Books, right? And back in the day, like most of you probably never even heard of them, but back in the day it was a big deal. I'd forgotten it. I'd written 7 Red Books, right? So I've written like 10 books. This is the one, I did this about a year ago. I think we're giving this out, so today or tomorrow maybe, but it's just audio only, and me and Gene did it. It's very geeky, 11 hours, and I would say one Audible credit, like to beg you to do it, but you're going to get a free one this afternoon or tomorrow afternoon. So I am working on 2 more projects, and this is the last shameless plug. I'm actually working with Shannon Leach, James Wickett, who are speaking tomorrow. Do not miss that presentation. Anytime you get to see Shannon Leach, you go to that presentation. She's incredible. And I don't know when it's going to be out, like hopefully end of next year. And then this is something even my close friends don't even know about. But at KubeCon, I'm doing something with Alan Schimmel from DevOps.com. We're calling it Digital Anarchist. So think Netflix for geeks. So we'll see. I don't know. We may like burn and crash all over the place, but it could be very interesting. So KubeCon. All right, spoiler alert, right? Okay, you came here to learn about next generation platform. It's containers and Kubernetes. We're done. I'll see you later, right? Let's go get a beer, right? But the thing is, it gets really interesting from here. And one of the things I'm not very organized as a person, but like when I see things that are disorganized in the way we talk about things, it drives me nuts, right? And so first of all, let's talk about Kubernetes for a second. I actually stole this from a Google presentation. So Kubernetes is a container management system, and they said, oh, no, it's not. Kubernetes is a container management platform. Oh, it's actually not. The truth is, Kubernetes is really like this kind of cyber incredible scale event loop, and we'll talk about the end. So in general, Kubernetes is really just an application on this thing. So we'll talk a little more about that. So it's kind of like if you know what it really is and where the future might be going, it kind of helps you a little bit. That may sound a little obscure right now, but hopefully near the end it will make more sense. But here's the thing, right? So like 4 years ago when I did the Docker for Manager, everybody's clear, good, we get it, thanks. Right now, it is the wild, wild west. It's a mess. It is incredibly messy. And not even the technology side of it. So here's the thing. I go into clients and I say, what type of container are you using? Notice I don't ask what Docker. Docker. Like, they don't know me. They're like, Docker, you idiot. I'm like, OK, what Docker? And they'll say the open source Docker. I'm like, well, respectfully, there's no such thing as an open source Docker anymore. Huh? It's Moby. OK? We'll talk about that later. Then you get to, like, OK, now can I ask you again what container system you're using? Oh, yeah, I just called our guy. It's basically Docker Community Edition. OK? That's the free one, right? Is that how you're going to run your bank strategy? Probably not. What are you going to do? I don't know. We're going to wait and see what Google does, right? Like, it's a mess, right? And then if you're OpenShift, like, I don't know if you are right now, but you will be cryo. And again, if these things don't make any sense to you, I'm going to cover them all. But the point is, and then the second question I ask is, what container orchestration are you using, right? Kubernetes, you idiot. And I'm like, well, okay, hold on. Which Kubernetes? And there's a whole shitload of Kubernetes distributions, right? And it matters which one you might pick or use and where you're going, right? When we talk about, and I guess what drives me probably the insane is when I see a presentation or somebody just talks about Docker as if it's a Frisbee or a Coke, right? And I guess in some sense that's okay. And 4 years ago, that was really the only way you described the system. But now today, I think we have to be a little bit better in having a conversation. So what I'm going to do in this presentation is cover really 4 categories. I want to talk a little about the foundations that are in place, basically OCI and the CNCF. And then we'll talk about the container ecosystem. And I'll try to put some names on it where we just don't say the word Docker. We actually start decoupling what it really means to run containers in a container ecosystem. And then I asked this in London, how many people know or have heard about the service mesh as it applies to Kubernetes? Okay, there was 3. And I don't count John. You don't count, buddy. He counts a lot, and watch his presentation Wednesday. But it's a very low number, right? And this is really important stuff for you to know about if you think you're going down this path of next generation, which today looks like it's Kubernetes, right? The distro, not sure. And then, if you don't know about that, wait till you hear about the thing that really is what all the cool kids are working on right now, which is called Kubernetes API extensibility. And I'll tell you, it's very nascent, but it could be some of the most important stuff we should be paying attention to right now. It could be. Right? So I'm going to give you a little bit of flavor of what that is and why it exists. So that's what we're doing. What's out of scope quickly is no introduction to containers, no introduction to Kubernetes. If you came here for that, there's just a gazillion of those online. I can't talk about storage network and ecosystem systems. I got 22 minutes left. Not that they're not really important discussions. It's just I'm going to be a miracle if I can finish this thing on time, covering the other topics. And then the only thing I'll say is serverless is you got Lambda and you got this new thing called native. Although that's another nascent. I think I get the sense of some of the people I talk to who I think are way smarter than me, that what we have is serverless right now will be completely different in maybe 3 or 5 years. So that's what. So that doesn't mean don't go out and use Lambda if for a digital property or something like that. But anyway, I'm already talking about it. No, we're not going to talk about it. So the foundations, there's really 2 that you need to know about. The OCI, and really OCI is about primarily about kind of the standards for container technology. Basically. Probably the most important one there is run C. For the most part, that has become the standard. So if you think what happened is Docker went ahead. So Linux containers had been in the kernel for quite a while. In fact, it was a collaboration, IBM, Google, and I forget who else. But and what Docker did, their brilliance was, it was really hard to get it in a way that was usable unless you were a geeky developer shop like Heroku or somebody like that. And so what they did is they put an abstraction around like C, and then they actually kept building that abstraction. They had something called libcontainer. And at some point, they felt that this was very commodity, and the industry was starting to split up on containers, so they donated what's called run C. So for the most part, people run C, and the ownership of that is part of OCI. There are some, in our industry, we don't argue, what are we doing, right? We love to argue about, especially when we try to spec thing and foundation, but one of the big arguments about the image specification and all that, and that's actually starting to get some grounding where there's still some downstream discussions between Red Hat and Docker about image, but ultimately everybody agreed that the foundation of images are going to work a certain way. And so the other project, oh shoot, we're missing a slide, darn it. But anyway, that's okay. I thought I updated it, but it's not really an important slide. This is the CNCF. So the CNCF is very important here. They're the primary stewards of Kubernetes. They are Linux Foundation based, which is good. So I'm trying to compare like the mess of OpenStack, right? The tragedy, the Titanic called OpenStack, right? Sorry if you're running OpenStack right now. Is this happening all over again? And for the most part, I don't think it is, because CNCF, first, it's Linux Foundation based. Linux Foundation, sorry, yeah. And the people that are running this they have their head together, and they're doing some things like on patent control, and if you join, there's certain rules you have to play. So again, follow this. A lot of activity, very interesting stuff, a lot of training. So you got your Kubernetes, and there's actually some interesting projects just since we're here that you should know about. And I'm not saying the other ones are not important, but Containerd, and we'll talk about Containerd and why it exists, and then which one? My glasses are on. Why am I? Hate when just getting old sucks, everybody. So just giving you a heads. Oh, Envoy, yes, of course, Envoy. We'll talk heavily about Envoy. But the one I won't spend a whole lot of time on is Jaeger. And then there's OpenZipkin. There's two of them. I'm not sure why Zipkin isn't. This is distributed tracing. Like, if you're doing greenfield, get your teeth into distributed tracing. I've got a couple of clients that have built head-to-toe composable data center infrastructures, and everything is running Jaeger. Like, the stuff and the value you can get out of distributed tracing is, like, off the chart. And a ton of other projects. All right, so that's the foundations. Again, we're running through quick, right? So the container ecosystem, right? This is the thing where I ask people, like, what are you running? They say Docker, and then we have this kind of decoupling of a conversation. And so I'm saying, like, if we want to decouple the conversation, then we really should be talking about container runtimes, engines, and orchestration, right? And if we want to get it right, really, not everything is Docker, and you may actually not be running Docker. So first, the runtimes, basically I told you is run C. That was what was donated. I think most of the different distributions of, like kind of the engines and whatnot are running run C. There are some interesting, run LXC is interesting. It's actually from Alibaba, and what they did is abstracted run C, run V, which is actually a KVM implementation. But the other thing they're trying to solve, which is interesting, this has been a kind of thorn between Red Hat and Docker forever. I mean, the idea originally of a container was it's kind of a single process or single PID mindset, right? You literally start the container, and the first process that's running is the application. And then those knuckleheads are I'm sorry, wait a minute. Wanted to put systemd in there, and it okay. I mean, I'm just kidding. I don't know what's best for your source, but it's been a little bit of like, how do you mitigate, like, should containers have kind of process control and stuff like that? And so one of the things that the Alibaba people did is they put a nice lightweight thing that kind of gives you best of both worlds. I think that's kind of interesting. So and then container engines. So like, if I said it's all Kubernetes, then any discussion about running containers outside of Kubernetes is a moot point, right? If you believe that, then the Kubernetes, its interface for running containers is called Container Runtime Interface, the CRI. And so under that, so you basically the flavors of engines is Containerd. So what Docker at some point wound up contributing not only run C, but they contributed their kind of engine, which is their daemon and all this like really good stuff, right? And so that became something that contributed to the CNCF. And so you have today Docker and Google, GKE, both run under Containerd. But Red Hat has gone down another path where they've created something called Cryo, which is their own implementation. So if you have OpenShift, you're most likely to be going down if you're not already into the Cryo path. And that's kind of a convergence. At the end of the day, they all run containers and follow the container spec, and they run C. So it's not the end of the world, except there is a little bit of divergence here. So when we talk about Docker, what Docker really has is the open source upstream is something called Moby. So what they did is basically they wanted to protect the brand. It was somewhat like the Fedora and for Red Hat and stuff like that, right? So they decided they were not going to rip out all this open source contribution. So they basically took what was GitHub Docker and called it GitHub Moby. It was a terrible. Is anybody from Docker in the room? Good. I can really talk bad now. I mean, it was a terrible idea. It was a terrible, terrible idea. But they did it anyway, and then they took the brand to proprietary. So basically, you have non-open source engine enterprise and engine community. It is the upstream, but like I just did the check. I've been checking like, is this thing working? The activity on Moby is not. I mean, it's existent because it is the upstream for the Docker stuff. But the point is, the only contributors, as far as I could tell, are the Docker maintainers that work for Docker. Like in the past, it was like a gazillion people contributing to Docker. What they absolutely did is like close the gate. They put like the Suez Canal in there. And again, I just don't like, that doesn't like, if we think about community and build and how we're doing things, it was a terrible idea. The cloud ones, just going through these quick, just like you know, you don't know. There are kind of as a service first based container. Amazon has ECS. Azure has ACS, and Google has GKE. Interesting about Google is you kind of get Kubernetes and the container thing together. They were doing that long before some of you were born. No, and so like by the time they were ready to make a service, it's like we don't need a container service. Like it's really just Kubernetes running these container things. ACS, right, if it's your stack, and then if you followed some of the announcements of where Google announced that Google Next about the things they're going to start putting on-prem. So in general, there's this kind of migratory path to being able to run both of those as a services to a certain extent, or some variant of that, on-prem. And we'll see where Amazon ends up in that war. So orchestration, I said, is Kubernetes. Docker originally had something called Swarm. Another terrible idea, where they literally decided at one point they were to combine their engine and their orchestrator together, and then within less than a year later decided to go with Kubernetes anyway. So actually what you do get in the Docker Enterprise solution is you get Swarm and Kubernetes together, but there's really no story for Swarm in my opinion. Although it was a great product, it just got swallowed up. And then you have Mesosphere. Well, interesting, and there's a whole bunch, and I'll show you some ones later when I go to some of the CNCF projects. But it was funny, Mesosphere, like a lot of the vendors out there, Docker, Mesosphere, they all were holding out like, no, this Kubernetes thing's not real. This Kubernetes, I found like one day, okay, we're all going to support Kubernetes. And I think Mesosphere might be one of the last ones because, and apologies to anybody who's Mesosphere if I'm using a little bit of literary license, but they argued that, and this is important, they were arguing that, yeah, that's all great, but we're the only one who do stateful clustering containers. Well, by the way, that's probably the primary problem that Service Mesh solves today, and certainly the API gateway stuff. So I'll talk about that. So that's like, okay, we've lost. And then the only thing I do want to mention, this was not on my list even in the beginning of the year. HashiCorp is just like that kid. I met him like 8, 9 years ago, Mitchell Hashimoto. So Nomad is an interesting story. One story is that, well, first off, it's incredibly easy to implement, and you can run your containers just fine. It's very lightweight. If you're doing like ephemeral batch and you want to build something that's going to go away, do you really want to build a very complex Kubernetes cluster? That's one. And then recently, I was actually, it's kind of already public, but one of the guys I know that's building Samsung's version of Siri, the whole data center is built on Nomad, Vault, and Terraform. And it's completely composable. And he cycles certs by the hour. He can build a data center, like a Siri-like data center in 30 minutes. So I'm like, okay, better start paying more attention to this thing called Nomad. Because the beauty is, Terraform's a great product, Vault's a great product, and if you want to run those two really well, guess who's the really cool solution? It's Nomad. In general, I will stick with the Kubernetes and containers is where all the mind share is right now. I just think you might want to put Nomad on your radar. And then there's a lot of ways to, those are a couple of distributions. I'll list a whole bunch more in a minute. But there's the classic Kelsey Hightower. It's a blog article. It's called Kubernetes the Hard Way. It's like, you want to really learn how Kubernetes work. It's a GitHub project. But some people tell me, I'll say, what, Kubernetes shouldn't like the hard way. Like we get it from GitHub, we manage it, we build it. There's all sorts of risk-reward discussions we can have about, distributed Kubernetes who add a lot of enterprise stuff, but some of it is actually really not open. And then others where you're going to have to do a lot of work yourself, but you have a complete path to openness. Right? There's a little bit of mitigation there. Here's the kind of list of there's like 42 certified Kubernetes from the CNCF perspective. But like you can see them, Canonical, Cisco. I mean, everybody's got one. Pizza Hut, I think, has one. But that was a joke. Come on. Docker, Google. Heptio is interesting. There's some of the original developers of Kubernetes. They call it kind of undistribution. It's an interesting thing to look at. Of course, you got Mesosphere, Red Hat. Again, more so these are the ones that I've kind of played with. So not so much that they're the best on the list, but they're ones I've... And then orchestration, like people run Kubernetes as a service. You got Amazon, EKS, Azure, and GKE on Google, right? Again, we're just kind of giving a landscape survey. So let's talk about service mesh, which I think like 6 people heard of it, so I got to go probably a little quicker now. So the service mesh is, it has broader definition, but in the context today, as we talk about Kubernetes, we talk about it as an infrastructure layer for service-to-service communication. It gives us the ability to lightweight proxies through deployment, but ultimately, what it does, it's basically a proxy, and I'll show you a little more detail here. But the idea is if you're going to run these they're called pods, if you don't know, but you'll run containers in a pod, and they're ultimately clusters. What you do is you put another container in there that is designed conceptually as something called a service mesh. And then from there, it sees all ingress, egress from that. And then in it, and there's rules and constructs that allow you to do observability, monitoring, traffic control, load balancing, service discovery, resilience, and we'll see some of this here in a minute. And so it's based on a very software-defined architecture. So if you know anything about software-defined networking, that's layer 3. It has got a control plane, data plane. Data plane is the packets. Control plane is kind of how you abstract the intelligence out of those packets. This is a layer 7. This is a proxy-based, but it's got the same architecture, but it's at a layer 7. And the data plane basically is really the proxy itself, and the control plane is kind of all the policy and the meta to make it work. And this is where we introduced the word Istio. So I wanted, how many people have heard of Istio? Oh, so a lot more. That's interesting. Okay, I'm asking the question the wrong way. Still probably less than only a third of the room, if that. So here's the deal. They're really, the way this is played out is there's an open source technology that was developed by Lyft. And they had a problem with scale, and they decided that Nginx couldn't solve their problem, and it wasn't written in a way they needed to run like containers and Kubernetes and all that stuff. So they wrote their own kind of proxy called Envoy. And so today, basically, the data plane is this thing called Envoy. In fact, at KubeCon, they actually have an Envoy day. It is really where all the work is going on, like the service discovery, load balancing, TLS termination, circuit breaker. It has built-in circuit breaker patterns, right? So it's already built in. It actually has some kind of deployment strategies like stage rollouts, and like you can actually augment it with like canarying and stuff like that. It also does like fault injection, and it's got chaos monkey-ish things in it. And then on the right hand, you have the control plane, which really is just all the policy. So at the end of the day, Envoy was this thing written by Lyft. They didn't really create a GUI or a way to kind of manage it. Google basically defined this thing called Istio, and think of it in a sense as a configuration management for Envoy. Although Nginx now is trying to create, or already has their own version of a data plane proxy. But right now, Envoy is taking all the oxygen. All right, so that's we just finished the first 3 subjects. Again, we're racing through a lot of stuff, right? But the last piece, right, is this is where all the cool kids are hanging out today. All right? And there's actually, sometimes the cool kids are hanging out someplace where, like, who cares? And sometimes they're hanging out in a place where we might actually want to care. And so I'll go through this reasonably quick. It's a very complex, it's very nascent. It's a really small set of people that actually can do this right now. It's so complicated. But it might have incredible impact on how, if the theory is that Kubernetes might be the 10-year winner from a platform structure. And there's a lot of people that kind of believe that. Now, there's a big if there. So that we might be running all our kind of clusters for the next, some people kind of put, like, maybe Kubernetes could be that abstraction of the kernel that just may be part of our way. And in a world where everything changes 3 years, that does sound kind of silly, but I'm buying into it for now. And if that's the case, then getting a jump start, at least understanding where this stuff is going. And by the way, the people who are going to give you the best intel on this are your vendors, because they're all doing this right now. So you can actually get them. Any of your vendors that are playing around with Kubernetes, you can pull them in and help you understand more of how this works, because they know and they're learning how to do it. Basically, AP. So Joseph Jacks, Gene actually put a thing on him this morning. It was kind of cool. He's doing an open source fund, but he's been heavily in the Kubernetes system. And you just quote at the beginning of this year, he said, all complex software delivered as a service or behind a firewall should be implemented as a set of Kubernetes API extensions and controllers. Radical efficiencies will abound. So his notion is, like, if you're SAP or your Workday or whatever, and the world is going to be clusters on Kubernetes, then this is an event loop that you can sit on, and maybe you should. So if you're doing greenfield development right now on some new project, and you think you're going to be on Kubernetes, this would be a nice time to do a little bit of investment on. I'm not telling you it works for you or it doesn't work for you. I am telling you that I have enough confidence that if you think Kubernetes is going to be kind of in your ballpark as something that's going to be around from a next. And I think when we say next generation infrastructure right now, most people would tell you it's containers and Kubernetes, right? So then the question is, should you get into this game way before anybody else is, right? Maybe not be an expert, maybe not re-architect stuff, but literally just start some POCs and projects to do some research on it. So the Kubernetes API, basically, I'm going to skip this slide because I want to go to this. Basically, the documentation is confusing as all get out. But basically, there's what you can call custom resources and aggregators, but custom resources are really the most important thing. Let me see something, make sure. I must have screwed around with my slides 2 minutes. I wanted to, yeah, I'm missing a very important slide, darn it. Oh, there it is. Yeah, so custom resource and control. So this is where you need the aggregator is interesting, but right now this is probably the most interesting. So you might hear them called CRDs, custom resource definitions. Basically, when you want to create your own, so if you, I know I'm sounding confusing here. If you think about, Kubernetes has some core resources, like nodes and replica sets and services and pods. And so really all you're doing is actually defining your own resource controllers, which is the execution logic for what you want to do, and then the resource definition. So a really simple example might be you want a stateful MySQL database in a cluster. So you might want to create that as a custom resource and custom resource control. In fact, Oracle has already done this and has a sample. But here's why. Because remember I told you earlier that Kubernetes is this thing that actually is much bigger than Kubernetes? It's basically an API that sits on a control loop that sees all egress and basically all ingress and egress, inbound, outbound traffic for everything that happens on a cluster in Kubernetes. And at a millisecond level, and it's Google saying it scales at Google scale. I mean, and that if anything I'm going to run on there, I can get in an API and sit on an event loop and be able to do anything I want from an operation, observability, right? Like, I hope some of you get the picture of, like, I think go back to Joseph Jacks. Radical efficiencies abound. I mean, I agree with him on this. I will say it's very nascent. It changes very quickly. The documentation changes quite quickly. But it basically, because what you have then is you have to create a custom resource. I talked about that. These create the kind of custom rules, and basically in events and what you want to do. Do you want to monitor? You want to change a cluster? You want to scale? You want to auto-scale, change pods? Oh, geez, I got a couple more seconds. But basically, one of the primary benefits of doing this is giving you the ability to do stateful applications. And then here's some of the examples that are out there, but there's a lot more. There's also, if you want to see all the community activity, going on here. It's just insane. You can list all the people that are actually pretty active in this custom resource thing. And the last thing I want to say, which I'm going to steal like about 30 seconds, is this is a movie from 1966. It's actually French, but there's subtitles called King of Hearts. Basically, it's basically the metaphoric, the inmates are running the asylum. So now I've told you Kubernetes and all that stuff is like the shit. I'll tell you right now, I'm scared to death that the people who are making all these decisions for industry might be the inmates in the asylum. They're young kids that are brilliant, that are moving incredibly fast. Things are changing really fast. So I don't know what the right answer is, but I do scare, it does, like, we need to kind of put the temperature gauge on and try to figure out how do we run a bank when every 3 months there's a bunch of smart kids adding all these new extensions. Anyway, thank you so much.